Susan play a game. In each child of the game, her probability of winning a doll is 0.6. Susan played the game until she win the doll. So until the first success appear is obviously a geometric sequence. So there is each child. And then we have two results, win a doll or lose. So 0.6 chance, this is 0.4 chance, this is each child. And then the total number of child need. The number of child need. To win the doll. Let it be X. And then it's follow a geometric distributions with P, that means 0.6 in this case. So part A, find the probability that Susan win a doll in the fourth game. Back to basics. We have four child in the game. So the only possibility, not earlier, not later, that means the first 3 times must be lose in a row and then finally win. So part A required probability is equal to Px is exactly equal to 4. So that means this one is 0.43 times and then 0.6 finally. So 0.0384. Okay, so this is part A, and then we focus on part B. If Susan cannot win a doll in K trials, after that, the probability that she win the doll within 10 trials in the game is greater than this amount. We need to find the largest value of K. So it's look like a little bit confusing. So let's us draw 10 space. And then what they say is already happened if Susan cannot win a doll in K trials. How many times we don't exactly know, we just approximately draw maybe until here. So this is K trial. Already finished. And then what coming next is we want to know if Susan can win within the rest. The final total probability is larger than 0.95 is what we want to know. So if K trials here, then here should be 10 minus K trial. Which means that the probability, what we need to find is Px. This is now. This is the past. We don't need to care, and we care what is coming. So x is smaller or equal to 10 minus k is what we want to ask. So the first method, more straightforward, is okay, x equal to 1 plus x equal to 2 plus until px equal to 10 minus k. More than that, we don't count because it do not fulfill our target. So if we very straightforward use this method, this is 0.6 plus 0.4 times 0.6 plus 0.4 square times 0.6 and then plus 0.4. This is 10 minus k and then minus 1 and then times 0.6. So after that, you may use the geometric sequence, the sum of geometric sequence to find out. If you forget, is Sn gs is equal to a and r power of n minus 1 over r minus 1. This is the formula. So this is 0.6 and then r is 0.4. Every term we have times 0.4 again. Power of 10 minus k minus 1 plus 1. And then this is minus 1. So after that, you'll find that we basically did some stupid thing. It's because this one can be cancelled out. So this is 1 minus 0.4 power of 10 minus k. This is the probability. And then that means, in other words, if we are talking about p, x, we back to this step, 10 minus k. If you foresee or understand what you're doing, that means is equal to all possibility, exclude the possibility that we all lose. In the rest, that means 10 minus k trial. So, a very straightforward method is lose chance 10 minus k times in a row. You get this one. So after that, don't forget our condition is the corresponding possibility greater than 0.95. This is the constraint for k. So that's why given 1 minus 0.4 10 minus k time power of 10 minus k greater than 0.95. This is the inequality that we need to handle. Then this is called math skill. 0.4 10 minus k is 0.05. In order to, because our unknown is the power and then there is a tools, we use log. Don't forget this bracket is give totally different meaning. Alright, and then 10 minus k, natural log 0.05, natural log 0.4. And don't forget that natural log 0.4 is a negative value. So it's trigger you to change the sign. So k is smaller than 10 minus natural log 0.05 divided by natural log 0.4. So we just use calculator. So k is smaller than 6.73 something times. And then they are asking greatest value of k. So greatest value of k should equal 6. That means in the very beginning cannot lose more than 6 times. Otherwise the possibility to win the dough is less than 0.95. Okay, part B, in each hour of the game, she need to pay $15. Find the expected amount of money she has to pay. So, first, expected amount of money is related to the expected amounts of game, number of games should be trials. So just testing whether you remember the expected value of a geometric sequence is equal to 1 over p. So in this case, it's talking about 1 over 0.6. Is this amount? So 5 over 3. And then so the expected amount is equal to 15 each times and then times 5 over 3. On average, every games we need 5 over 3 times to get the price. So it's $25.